Okie dokes, we have a physics question here. Actually, I guess it's a series of questions. Just some true or false questions here. About circular motion. Okay, so we have a magnetic ball that's revolving in a circular path. So here's our ball, and it's revolving in a circular path, okay, around a cylindrical magnet. Okay, so this dot right here is our cylindrical magnet. Okay, so let me just quickly summarize circular motion here. So my diagram that I drew here, the green circle represents the path, okay, hence these little arrows, okay, that's just the path. Here is our object that's rotating, okay, in our case it's a ball, and here's the point, the center of the circle, or the point about it which it's rotating. The line right here, okay, represents a force, okay, and that is the centripetal force, or the center-seeking force that is present in all types of circular motion. Okay, I actually drew it as a line here because it's best to think of the centripetal force as being a cord. In fact, whenever you have a ball and a string, that's exactly what's happening. So the cord is essentially providing that force. Okay, so with that in mind, let's take a look at the first question here. So A, the ball is not accelerating. Okay, I just said that what is keeping the ball rotating is that center-seeking force. And if you remember, force is defined as the mass times acceleration. So if you have a force, your object has to be accelerating. So that makes this part A false. Okay. All right, and I can also go ahead and draw a arrow indicating a force here. Okay, the centripetal force. Okay, so B, the ball is accelerating with the direction of the acceleration pointing toward the center of the circle. Yes. Okay, so that is true. Like we just said, whenever you have an object in circular motion, you have a center-seeking force. Okay, so the velocity of the ball remains constant. Okay, this one is a little bit tricky because it says that the ball is revolving at constant speed. Okay, well, if we have a force, okay, we have an acceleration, therefore velocity cannot be constant. Okay, well, why is that, you ask? Well, because the ball, although maybe it's traveling at a constant speed, it's constantly changing direction. Okay, therefore the velocity vector is always changing direction. So even though the magnitude's not changing, the direction's changing, therefore it is changing. And that's actually where that centripetal acceleration comes from, is from the constant changing of the vector. So C is false. Okay. D, the velocity of the ball remains tangent to the circle, and therefore the velocity cannot be constant in direction. That's actually true. That's just what we were talking about. Okay, because the velocity is always pointing tangent to the circle, therefore it's constantly changing direction. Okay, so it's not constant. So D is true. Okay, and then part E, the last part, the ball is accelerating with the direction of the acceleration in the same direction of the velocity. Okay, so that right there is false. Okay, that's because the only acceleration in this case is inward from that center-seeking force. Okay, now if the ball was had a accelerating angular velocity, right, or it had an angular acceleration, then this would be true. Okay, but in our case that's not the case because we're rotating at a constant angular velocity, okay, or constant speed in this case. All right, I hope that answers your question. Thanks for watching.